No, not yet. But we kind of have. We weren't meant to. Yeah, I stuffed up. Yeah. Let's be honest. Okay.
No, but we didn't do this, did we?
No.
It's an easy way to work with it.
We did the first bit, and then we didn't do
Okay, so compound interest. Okay, we're actually doing compound now. Now, as we notice with simple interest, over the years the interest doesn't change. It's going to be the same. Whatever the starting value is, we add it on or we take it off each year. Compound interest changes. Okay, so as we go on over the years, it's going to change. It's going to go up or down depending on what happens. Essentially what that was all talking about. So, alright, so we're going to start by saying Vn is the starting amount. Right, we got $1,000 invested for 4 years. Okay. So invested means we're putting it into a bank and hopefully we get money out of it at the end.
So should we just write what you were writing?
Yeah. Right, so I'm just saying we got $1,000 invested, 4 years, interest rate 12%, and it's compounded. The interest is compounded.
What's the I dot I? Maybe it's
The what?
I dot I on the board.
Interest rate.
Ah,
yeah. Okay, so we want to make up a table for compound interest. We're after 4 years, so we're going to go up to 5. Okay, because that's our first year. Our first year. Okay.
Yeah.
After 4 years, we're going to have in our 5th year. Just bear with me. Yeah.
Just a question. Yeah, you and the V.
Yeah.
So you feel like what's the difference?
Not really much difference. It's just how we label it.
Right.
Doesn't matter. I've done.
So if I
This
type the
V.
V where there should be a U, does it matter?
If the question like this says V of n, use V of n.
Yeah.
Okay, but if anything else, then it won't really matter.
Yeah.
Yeah. So I could have said T of n or something like that. So you use T.
Yeah.
Yeah. Right, first year. What's our starting amount? 1,000. And our interest is therefore going to be 12% of that number. And this is what we did the other day. So what's 12% of 1,000?
120.
We can say 12 over 100 times 1,000. Okay, and that gets 120. So how much is our next term? That's going to be this column plus this column.
1,100.
Yep.
That's solid colourblind.
I was looking at that.
Okay, go on to the second year. What goes in here? It'll be this column here. So 1,120. In here we've got interest. Does the interest change? Okay, it's still 12%, so 12 over 100 times, okay, 1120.
Oh, yeah.
Is 12% of like? No, I didn't. I swear on the line. It's 10%. Thanks. No, we're not friends.
Okay, finish off 3, 4 and 5.
Hang on.
What?
I didn't say decimal. I thought it was 1,344.
Oh, you're an idiot.
What do you get for this one in this number?
I haven't got onto that yet.
Three is 150. 5
Yep. And then that plus that.
1,404. Wait. 93.
Shut up, you need to leave. You knew something for it.
Can that black get a look good?
Can you spell 4 for me, please? Nah, it's how you're supposed to spell it.
Oh, shit.
Oh my god. Jesus. Look at that last one. It's like big enough for it. Oh, yeah. Pretty. Look at this. Missed the whole.
That's gross.
Good on you. Yeah, right.
Okay, so that's essentially compound interest. Not too much different to simple interest, it's just this changes a bit more calculations.
Oh, 1, 2. This is real. How is he so hard? Just writing it down on the board. Oh, yeah. That's yeah, sure. You? No.
No, I said I need to
Oh, really? Oh, no.
Let's put them on the same.
Oh, yes, me?
Is that what I said last session?
Okay, so once you've copied that down,
Excuse me. Yes.
Oh,
Balance.
alright, I'm going to make another table. Same question, just something different. So I've got the times down the bottom. My interest is 12%, so 1.12 times 1,000, which was my initial number. What does that get? In your calculator, what do you get? Okay, 1,120. Let's have a look at this one.
Oh, that's just an easy way.
Do that. Oops, 1.12. Sorry. 1.12. I'm going to do it twice.
1.1. Plus or
Times.
Uh, 1,254.4.
And we'll do it again. What do we do here?
It's going to be 1,404. Let's be honest. You're going to go down with
Alright, 1, 2, 3 times that. And if you do that in the calculator, you'll get 1404.93.
That makes a lot of sense.
Okay, so
fourth time we've got to do that.
yeah, so multiply that out 4 times.
That's so cool.
So what's actually happening over here? So we've calculated 12% of our initial investment of $1,000, and we added that onto our initial investment. Okay, if we do it twice, How can I show you this?
Look at me there. It's going to be ruining my, like staring at you. And then she, I can see her looking at me and it'll do it. Oh, yeah. Oh, yeah. Oh, yeah. Oh, yeah. Oh, yeah. What? Just a random comment. Just, is huge. Yeah, let's critique their day. It's really weird about it.
You agree? Shut up.
Okay, so what we're doing here is from this table, our first one, we just got our 12% of 1,000. Okay, gave us that number. Now we do it twice. Okay, we've done our first time, we're doing it a second time. That's where that comes from. Gives us the same answer. So it's two different ways of doing it, and I've just done it in decimals on this side. Okay, so we're kind of starting to do a bit of a formula.
Oh, yeah.
Listen up, mate.
Oh, yeah.
Yeah.
Oh,
Yeah. You're probably over there.
yeah. Yep. Oh, yeah.
Okay, we're multiplying two numbers that are the same here. Okay, that's squaring it. Alright, if you do it 3 times, it's going to be cubing it, and 4 times, it's going to be to the power of 4, 5, etc.
So say you wanted you just got asked if you get the fifth term.
Yeah.
You just do 1.12 times, like 5 times over.
Yeah, so you'd have 1.12 to the 5.
Yeah. So it'd be another way you can just skip all that as well.
Yeah.
Right.
Yeah, so that's kind of a bit of a summary. Alright, so that's what we've done here. Over here. So we actually get okay, 1.12 to the power of n, that's going to be our number of years, times our initial value, which was 1,000.
Okay.
Alright, let's have a go at this example. Can I rub this off, or are people copying it down? Okay, so this example, we're just filling in the letters. So A, B, C, D. So you've got to work out what they are.
Right.
A, B, C, D, E, F.
Hang on.
Yeah. Yeah, I wouldn't put it in that.
Sure.
No, you still got to work it out.
So A,
You know what I mean?
what's that? I use 8% because it's, yeah. So B should equal 1 8. Oh, yeah, 128. B should equal
Okay, so our initial value was 2,500. A, what's that? That's our interest rate, which is 8. And we work out 8% of our initial value, which was 200. Add that on to our initial number. So this column plus this column gives me this column.
Yeah, that's for B.
So now B is going to be that number. So 2700. 8% of, and what's C going to be?
Hang on, wait.
Initial value 2,500.
Please be blank.
27,000 again.
8% of 2,500.
You laugh.
No, A is the missing number here. That's 8, because that's our interest rate. So A has to be 8 because we've got 8% per annum. So 8% of 2,500 is 200. And then we add this column and this column to get this column.
Give me back my white out and check.
And that goes, B goes into C as well.
Okay, so in here we get that. Now that number there comes from that column, so
That goes there too.
I remember you telling me that. You said
okay, that's that number. Okay, so what's this number?
That would be 1916.
Okay, because it's this number plus this number, oops, here,
Yeah.
equals that number.
It's going on.
Yep.
not one. Yeah, Mr. O'Connor. It's 2916.
It's not my car.
Yeah, it's 29.
Yeah, you meant 2 9.
Yeah, you meant 29.
That's not thanks, Lewis.
Oh, would you show us Bailey?
Okay, so E is going to be this column equals that column.
What, 3149.28 plus 251.24?
Yeah. And then that number there is going to go in there.
Yeah.
So this is all just tables, this part. We're just going to bring it into tables.
Yes. At the moment.
Yeah.
Yeah, so that's basically.
Got a question there?
Yeah, I haven't put them in. I'll put them in.
Ah, yeah.
rub this off? Okay, so that's 6.3. Now we'll go on to 6.4. Yeah. So that was pretty short. Okay, so 6.4.
What's his strategy performance so far?
Compound interest formula. So this is kind of summarising what we did before. So we can say from previous exercise we can write it as terms of the previous value. So we've got our next value is going to be our previous value times R. So what's R going to be?
R is the interest rate.
Yeah, the growth rate of the compounding factor. So we actually work out R as one plus. Okay, one. Okay, that comes from. Remember we had 12%. So we say little r is 12. So 1 plus 12 over 100, and that's where we get 1.12. So that's where we got 1.12 for all this.
So we should probably write it.
Okay, so that big. So you got little r and big R. So our growth rate, or the compounding factor, is going to be this big.
Good. Should we write that down?
Yeah.
Even that.
Mom, that's a
Okay, so who recognises this recurrence? From 5.3. Yeah. Yeah? Kinda?
Sort of.
Okay. Simple interest, we were adding something. We had that formula where we add something.
Yeah.
Okay, what do we do on this one?
Adding
Previous
times
Times it.
What's the R doing?
So what's that going to do? Remember, okay,
Oh, that's going to skip it, isn't
It's
it?
not going to be linear.
when we had a graph, this was a linear, as we saw last lesson. We had all these points and it made a linear graph. What do you reckon this one will do?
Make it non-linear.
Non-linear. Okay, remember graphing those?
Yeah.
When we multiplied something, we had something that went steeper or not as steep. Okay, so that's what we're kind of looking at. So this is compound interest. We're going to go steeper or... Okay, so like with our simple interest, where we kind of skipped the middle terms. So we said after 5 years, what's our interest rate going to be, or how much do we earn, or whatever. Okay, so instead of writing a table each time, we used I to skip all those numbers, I guess. Okay, similar case for here. At the moment, we've got something and we have to make that table every time. Because we have to use previous value. Now, we can skip ahead a little bit. So we can use this, our initial value times our R, growth rate. Yeah, and that's to the power of however many terms there are. So after five years, we'd have R to the power of 5. Yeah. Yeah.
So we should write down what are they?
Yeah.
So we should write down the compound characteristics.
Yeah. Okay, I'm going to go on. That's on page 257. We can go back to that.
Should we cover that down?
Okay, so that's just talking about finding our interest compounded. So that's just saying our final number. What was the example we had before? What did we get as our 5th year? How much did we earn?
Which example?
157.3.35. Is that what it was? On the table.
Yep.
Oh, and yeah.
1,573.35.
1573.
0.35.
Okay, and our initial. How much did we deposit?
Oh no, the
1,000.
last value was 1762.34.
Oh, yeah, you're correct.
Uh, 1762.
34.
So after 5 years, we have this much in the bank. Our initial value was 1,000. What was our interest that we earned? Well, it's going to be this number, take away this number. Which is 762.34. So over 5 years, we earned $762.34. That's all that's saying. So I, which is our interest compounded, is going to be our final number, take away what we deposited initially. Alright, again, the solutions are there, but let's work through this one.
So
we've got $5,000 invested, 4 years at 6.5 per year, and it's compounded interest.
so you
Annually?
got one. Compounding factor, is that what they call it?
Generate the compound interest formula.
So that's the 1 plus R over 10.
Which one do you want to use? This one or this one?
How do you know? What would be the other one? Oh, I know. UN.
Alright, again, does this have how many years? Remember, R is.
Yeah. Right.
Does that one have number of years?
No.
No. Remember, we have to. Remember this one, we have to do our table.
Yeah.
Okay, so we find the first year, second year, third year,
That
fourth
one
year.
don't.
You can do that, or we can use this one, which kind of skips ahead.
Yeah.
Okay, so what goes? Okay, so instead of R, I'm going to write what R equals. What's V naught?
That's the starting page.
Yeah, how much did we invest? 5,000.
5,000.
What's little r?
That is the interest rate, which is 6.5.
Yep, 6.5. And to the power of n, what's n? 4 years. So put those numbers in your calculator. And what do you get? Oh, sorry, we don't need to know. We just want n there. Putting 4 in is part B. So part A, we just want the formula, which is this. Just simplify it a little bit.
So you use this one when you want to find out just a year. Is that right?
Okay, now we can use this formula to calculate part B, which is 4 years. So after 4 years, we'll have then put that in your calculator. just need to calculate how much interest did we earn over that period. It's going to be our final number, take our initial number.
$1,432.33.
Yep. So, not really that much difficult,
Yeah.
is it? Again, what's the hard parts?
Working out what we're going to use.
Yeah. Which one do we want to use? This one or this one?
So that one we just
put in
use
numbers
to
in.
find out the year,
Yeah.
and the other one's to make the table.
Yeah.
That one there.
Yeah.
So easy. Is it
Okay, I want to get through this. We're nearly done. So we're just looking at non-annual compound
Is it
interest.
or
Yeah. So this is non-compound interest. So we've been looking at after 2 years, 3 years, 4 years, etc. Sometimes they ask us, okay, it's going to be every couple of months. It might be 3 months, 4 months, could be half yearly. So we're going to try and work out how we can calculate those. So this is non-annual compound. Okay, similar to what we did before when we had 18 months. So we've got number of interest periods is going to be the number of years times the number of interest periods per year. So they'll tell us, okay, interest periods of 3 monthly or half yearly or whatever. Okay, so number of years might be 4 years. Interest is going to be every 3 months. So we'd have 4 years times every 3 months. So how many interest periods are there? We have 3 months.
yeah?
What? Okay, you got 3 months.
Yeah.
You're going to pay it every 3 months. How many times a year do you have to pay that?
4.
Okay, 4. So it'll be 4 times 4, so it'll be 16 instalments in total over 4 years. Just as a side example. And we also get interest rate per period is going to be the interest rate per annum. So per, what do we say, 3 months over 4, because there's 4 periods per year. Just a little table, write those down. Just conscious on time, so one example to get through. So we've got $3,200 invested for 5 years, 6% per annum, quarterly. Okay, so we want to find the number of interest periods, N. So over 4 years, how many interest periods are we going to have? Over 5 years, sorry. 20. Okay, because quarterly means we've got 4 per year and we've got 5 years. So it's going to be 5 times 4, which is 20. Part B, what's the interest rate per period?
6.
Alright, we've got 6% per annum.
Oh, so be.
Okay, so 6. And
That'll be over there.
oops. That's alright. Yeah. Part C, what's the balance of the account after 5 years?
So you
Go
go.
just do it. Instead of you replace your end value with 16, with 20. So
Set up your formula first. What do we have? Cn? Yep.
Oh, yeah. It's going down like 25%.
Okay, we want to use that formula.
So U0 will be
instead of
3.
using 5 years as the end value, use 20 months.
Big R is going to be 1 plus. And we'll have 5 here. What do we get? What was it? Yeah. Okay, so after 5 years, okay, so I'll put the questions up. Start, at least get 6.2 done. Okay, work on those.